Alright guys, so today what we are going to be talking about is what makes something a rational, what is rational or irrational. So we are going to be talking about the difference between rational and irrational numbers today. The first thing I want you to notice is in the term rational, we actually have the word ratio. So any rational number, the easiest way to remember rational numbers is that rational numbers can be expressed as a ratio. I'm sorry if this typing is super annoying hearing it. Testing out a new format for these videos. So these can be expressed as a ratio. Now, if you can't remember what a ratio is, basically it means a fraction. So examples, or let's back up a little bit, can be expressed as a ratio or a fraction. So literally anything that can be shown as a fraction is rational. So examples of this obviously would be 5, 3.2, 1.3, or 2, 3, 4, 5, 6, 7, 8, 9, 0.33333333, repeating. And you might be thinking to yourself, well, that doesn't seem rational. Well, remember that that can be shown as one-third. Therefore, it is rational. The easiest way to think of this, let me tab this in so it's easier to see. The easiest way to think of this is, what are the look-fors? The look-fors are or rather repeating decimals, terminating decimals. So what I mean by that, a repeating decimal would be, of course, something like, as we saw above, 0.33, repeating. Let me get rid of this ellipsis. 0.3 repeating would be an example of this. Let me pull that up, wherever that happens to be on here. There it is. So 0.3 repeating, 3 repeating would be a repeating decimal. Terminating decimals mean that any decimal that ends. So as we saw above, 3.2, 1.2, 3, 4, 5, 6, 7, 8, 9. There's no ellipsis after that. I should get rid of this. There's no ellipsis after that, therefore it ends. It is done. It has terminated. Therefore, it is rational. Obviously, other things that are terminating decimals are any number without a decimal, because that would be 5.0, and that ends right there. So those are rational numbers. They are anything that repeats or terminates. Now let's talk about irrational. Well, hopefully you figured this out. This is any number that cannot be shown or expressed as a decimal, or as a fraction, or as a ratio. Examples, non-repeating, or basically the idea is non-repeating, non-terminating decimals. Examples would be, well, the easiest one you should probably know is pi. Pi is non-repeating. Where is it here? Pi is non-repeating, non-terminating. It continues forever. Another example, I don't want to capitalize. Another example of this that hopefully you know is phi. Phi is known as the golden ratio. it is non-repeating, non-terminating. A non-example really quickly, or rather a watch out for something like this. And these pop up more frequently than you would expect. Watch out for them doing something to the effect of pi over another number. Now, hopefully, you can see that pi over, let's say, 2, well, hopefully you can see this is irrational. The reason being, you can't actually even finish writing this. It is irrational. It will still end up as a non-repeating, non-terminating decimal. So if there is any irrational anywhere in the term, an irrational value anywhere in the term, the result is irrational. Meaning if you divide an irrational number by 2, the result is still irrational.